Okay, hello. So today we're going to do Unit 2 Day 5 notes, which is basically graphing by hand and determining whether an order pair is a solution to a function. So as you already know that a linear function has an exponent of 1. Now, these linear functions have different forms, but one of the ones that we're going to focus on throughout the year is slope-intercept form, which is y equals mx plus b. Now, for right now, the only thing you need to know is that the m on this form is known as the slope, and the letter b on this form is known as the y-intercept. Now, obviously, you have no idea what the meaning of slope and y-intercept are, but we will further discuss that in Unit 2, Day 6 notes. Okay? But for right now, let's just focus on learning how to graph a linear function. Okay? So if you don't have a graphing calculator, obviously you're going to have to graph by hand. And one of the easiest ways to graph by hand is by creating a table so you can get yourself some ordered pairs. So let's go ahead and move to example 1. Now, obviously, I've given you a table and a grid so you can be able to graph. Now, to be able to start this, you need some x values. Obviously, you can choose any x values that you want because those are the input. So you can decide to do negative 100, negative 1000, whatever you decide. But my advice is when you're picking your x values, I would just keep to the basic easiest numbers you can choose. So negative 2, negative 1, 0, 1, 2, 3. That way you have a balance in between 0, a few numbers above 0 and a few numbers below 0. But if you had to be consistent when you're graphing by hand, try to choose these numbers. I mean, obviously you don't have to do all of these numbers, but I would just choose like 2 negatives, the 0, and then 2 or 3 positives. That way you can get an idea of what the graph is going to look like. But if you're graphing by hand, stick to these numbers, okay? Obviously you can pick any numbers you want, but just to make it easier on you, just stick to the numbers between negative 2 and positive 3, okay? So anyways, the idea is that you're supposed to take each x and input it into your equation, which is the machine, and then out comes the y. So in goes the number, we do some math, out comes another number, and that's how you get your ordered pairs so you can be able to graph. So let's go ahead and start with the first number. That means this is my x value, and I'm going to plug it into this equation. So I'm going to have 2 times x plus 1. So if I plug in negative 2 for the x, where the parenthesis is at, that should give me an output. So 2 times negative 2 is negative 4, plus 1 is negative 3. Okay? Now, let's try the next one. Remember that the x goes away because that is what we're going to be inputting for each. So I'm just going to go ahead and write down 2 times whatever plus 1 because that's where the x is going to go every single time. So now for the next number, instead of the x, I'm going to plug in negative 1. Okay? And I like to highlight so you can see where I'm getting that number from. So let's go ahead and do some math. 2 times negative 1 is negative 2 plus 1 is negative 1. Okay, next one. And the number I'm going to input is 0. So 2 times 0 is 0 plus 1 is 1. Next number, I'm going to input a 1. So 2 times 1 is 2 plus 1 is 3. Next number, in goes a 2. So 2 times 2 is 4 plus 1 is 5. And the last number, in goes a positive 3. So 2 times 3 is 6 plus 1 is 7. Okay, so as you can tell, there's my x's and my y's. So if you're still confused, your first order pair is negative 2, negative 3. Second order pair is negative 1, negative 1. Next order pair is 0, 1. 1, 3. 2, 5. 3, 7. So there's all my order pairs. Now what I'm going to do is I'm going to take these points and plot them on my grid. So now my first one I said was -2, +3, -1, -1, 0, 1, 1, 3, 2, 5, 3, 7. Okay? Now, you can take a ruler and connect your dots so you can get a better sketch. And there's my points. And because this is a function, I will go ahead and add arrowheads to indicate that this graph goes on and on forever. Even though we only have 6 points on our table, this function goes on and on and on forever in both directions. It's just that we're drawing a sketch and we picked 6 numbers to represent that sketch, but really there's a whole bunch of numbers, a whole bunch of points on this line that it goes on and on forever. Now, if you wanted to just check your graph, you could always go to your graphing calculator, okay? And you will need to click the y equals. Once you go to the y equals, you will go to the place where you can input your function. And as you can tell, y1, y2, y3, y4 are already in there. That's just automatically the y equals, okay? And if you wanted to put more than one equation in there, you could. You can actually put up to 7 equations if you needed to. But we only have one equation right now, which is 2x plus 1. So we don't have to worry about the y equals part. All we have to worry about typing in is the 2x plus 1. So let's go ahead and do that. Click 2. And then the x will be right here. It's beside the green button. And then plus 1. Now all you have to do is click graph. And there's my graph, which you should recognize as it being very similar and very identical. Okay? Now, let's say I wanted to check my table. Well, if you go to second, so the blue button, and then click graph, it takes you to the table of that function. And if you compare it to the one we have, you will see that the same x will give you the same y. Same x, same y. Same x, same y, and so on. And as you can tell, this is a true representation. This table is a true representation of the function because this table goes on and on and on forever in both directions, in the negative and in the positive. So we don't have to worry. So if you ever needed to find out a specific y value of an x for that function, there it is, because it goes on and on and on forever. Okay? Now, let's go ahead and move on to example 2. And yes, we're going to be graphing these by hand. You can use the calculator as a way to check your work, but really, we're not going to be using the calculator to graph. We want to master the skill of graphing without a calculator. Okay? So let's do example 2. So obviously, I'm going to do -2, -1, 0, 1, 2, 3. Now, if I plug in the x's into my equation, I should get my y's. Now, I'm just going to quickly write 3 parentheses minus 2 over and over down my table because it's the same x that I'm going to be replacing. So it just makes it easier. So in goes -2 and out comes -8. In goes -1. You do some multiplying and some subtracting and you get -5. In goes 0 and you get -2. In goes 1 and you get 1. In goes 2 and you get 4. In goes 3 and you get 7. So your first order pair is -2, -8. Next one is -1, -5. 0, -2. 1, 1. 2, 4. 3, 7. Okay, so now I'm going to plot those points so I can be able to draw my linear function. So -2, 8, -1, 5, 0, -0, -2, 1, 1. 1, 1 is up here, my bad. So ignore that point, that's a mistake. 2, 4, and 3, 7. Okay, so of course ignore that little dot. And there you go. Just double checking that all my points are correct. So anyways, yeah, there's my grid. Right there. Ignore this dot, that was a mistake. So that dot is not part of our graph, but the rest of it is. So there's your line, okay? So let's go ahead and move on to the next problem. Now, the next thing you will notice is trying to determine if something's a function. So doing this is the same thing as the table. The only difference is that you're only doing it one at a time. So let's see if this order pair is a solution to y equals x plus 5. So obviously this is your x, this is your y, so if you input 1, they're saying that you're supposed to get 5 as your result. So let's do that. So let's do 1 plus 5, because instead of the x, I plugged in a 1, so 1 plus 5 gives me 6. They said I was supposed to get 5. I got 6, so this is not the answer. Let's try the next one. If we do 5 plus 5, that gives me 10. They said I was supposed to get 11, so that's wrong. Next one. If I do, instead of the x, I do 2 plus 5, that gives me 7. I did get 7 just like they told me. So this is my answer, okay? Because I got exactly what they told me. This is a solution to that function. Okay? Example 4. Now, this is your x, this is your y. They're saying if this point lies on that equation. Now, the easiest way that you can determine if that order pair lies on that equation is to plug it in and see if you get the output. Okay? If you plug in the x and you get the same output, then it is a number that lies on the line. Another way that you can do this is if you graph this function. So let's say this equation, if you were to graph it, let's say we come out to be something like that. It's a random sketch, okay? It's not an actual sketch of that graph, but it's just an example. So let's say I graph this equation and I find this point, 9, 10. And let's say 9, 10 comes out to be here. Does it lie on the line? No, obviously. But if we did 9, 10 and it came out to be that it's on top of the line, then the answer will be yes, it does lie on it. But if it's not on the line, it does not lie on it. You could do that, but that will take you a while. So the easiest way to determine if this point lies on that equation is to simply just plug in your x, do the math, and then see if you get the same y. So if it comes out to be a solution, then yes, the point does lie on the line. If it doesn't come out to be a solution, the point does not lie on the line. So it's just like the example we did up here, number 3. So let's just go ahead and plug in the 9. So instead of an x, I'm going to put a 9. So 9 goes in here. So 7 times 9 gives me 63. And then take away 11 and you get 52. So they said I was supposed to get 10 as my output. I didn't. I got 52. So that means this point is not going to be on the line. Okay? It's not a solution, and it's not on the line. That means it's going to be a random point somewhere. You're going to have your line, and you're going to have a random point. So does the point lie on the equation? No, it does not. And that should be enough justification as to why it does not. Okay, the next section you can do by yourself. If you have any questions, please do not hesitate to ask me in class tomorrow. But I am going to do the challenge question real quick, and just know that you can simply create a table, and you can choose your numbers, -2, -1, 0, 1, 2, and no matter what x you input into this equation, your y will always equal 3. because that's the only thing that's in there. There's no x. So if you plug in -2, there's nothing to plug in, so it's always going to come out to be a 3. So anyways, these are your order pairs. And if you were to graph these order pairs, it would just be a simple horizontal line. Okay? So, there you go. And of course, like I said, if you have any questions, do not hesitate to ask me in class tomorrow.